Okay, so now we're down to section 4.1.3, and we're going to talk about type systems here. Now, so far, we've gone over a couple of sections in this particular chapter, and I'm breaking it out into small pieces so that you will be able to basically digest it. Because again, it's going to get overwhelming, but I'm taking my time to help you to really get through this curriculum one step at a time. Because if you already read this chapter before you saw this video, did I kind of enlighten you on a few things? Did you overlook some things and gloss over some things because, oh, you didn't know that you should do that? Well, don't worry about it, because that's how we all were. And this is what we're here for as your TAs, is to help you get through this curriculum and break it down to you so that it makes sense. So now let's get back to this last little part of this section, which is 4.1.3. So 4.1.3, type systems. For every programming language has a type system, which is the set of rules that determine how the language deals with data of different types. In particular, how values are divided up into different data types and one characteristic of a type system. In many programming languages, integers and floats are considered to be different data types. For example, in Python, 42 is of the int data type, while 42.0 is of the float data type. Notice the two, these are keywords, int and float. We don't have this in JavaScript, as you can see, it's in this note. While JavaScript does not distinguish between floats or integers, at times we may wish to do so in our programs. For example, an inventory tracking program stores items and the number of each number in stock. Since a store cannot have 3.5 shirts in stock, the programmer makes the quantity of each item integer values as opposed to floats. When discussing the difference between programming languages, the details of a type system are one of the main factors that programmers consider. There are other aspects of type systems beyond just how values are categorized. We will explore these in future lessons. Okay, but something that I've been promised you that we are going to look at before we go any further, and you're going to go over this later on, but I want to introduce it here. And let's go to Google, and we're going to type in primitive data types in JavaScript. So let's go there. And of course, I want to do this one right here with MDN Web Docs. And it says here, in JavaScript, a primitive or primitive value, primitive data type is data that is not an object and has no methods or properties. We're going to talk about that later when we deal with methods and properties. There are 7 primitive data types. Here they are: strings, number, big int, boolean, undefined, symbol, and null. Most of the time, a primitive value is represented directly at the lowest level of the language implementation. Pay attention to this paragraph here. All primitives are immutable, means that is, they cannot be altered. It is important not to confuse a primitive itself with a variable assigned a primitive value. So what does that mean? When we start really getting deep into variables coming up in this chapter, you have to understand that that variable is a container and it holds a value. So don't get the string confused with the variable. The string is a primitive data type. It cannot be altered. But that it doesn't mean in that variable that it can't be changed. And we'll show you that later on. So what I want you to do is kind of read this, Here's a link for it. I would type it in, look at it, and go over it. It's important that you begin to understand how this works. And here, we said that we're going to explore this in future lessons. I hope you checked your understanding. And like I said, go back over these videos after you get through the chapter. Bookmark them. On my channel, go ahead and subscribe and hit the notification, so every time I upload a video, you will get a notification. Because the more you practice, the more you will improve. All right, I'll see you in the next video.